Good afternoon. I'm here to talk about something that has been spoken about much before. I had a lot of build up to it, but then I didn't realize that the velocity of change was so fast that between the morning and my talk, many people have already spoken about the microbiome. In fact, I wanted to start with this. I'm sure all of you have already heard about it. I've seen it several times. I think, therefore, I am. This is what Descartes said in 1637. Of course, if Descartes was here now, with all the access to information, data, and everything else that he knows, that we are just not, there are several other beings that make us us. I'm sure Descartes would have said a little more. He wouldn't have said cogito ergo sum. He would have probably said cogito ergo sumus. I think, therefore, we are. So having said that, I was told to give a background of us and the company before I move ahead. So we are, the word systems biology, has been used extensively several times here. So we are a company we are a microbiome company deeply embedded in systems biology. In fact, I worked in telecom and in cities. Chiranjeev is just gone, but one of the things that came out of here was what's called the Indian Urban Data Exchange. The genesis of that was a project that we did where we put in data from across cities and even functions within cities to understand the whole. So that's me. I want to put Gaia. In fact, the earlier company was called Gaia. I want to put the image of Mother Earth there, but I thought this was far more better. This is a picture from the telescope Gaia. And the telescope Gaia, this is a picture of 12 billion years ago. It looks at one of the first interconnected systems, the two streams of stars. That's on the Gaia piece. My other two colleagues, the two partners, one of them was one of the founding fathers of systems biology. In fact, he wrote the first textbook on systems biology. That's one. He's Japanese, Hiroaki. And Samik pretty much authored what's called the systems biology markup language. So yes, our principles, philosophies, and systems are deeply rooted in computational systems biology, interconnected systems really, which is why all of these. I'm here to talk about this study that we did. Actually, if I had known IISc was doing this Longevity India thing now, we wouldn't have spent all this money on the study. We closed the study early this year, January 2024, but we began this in December 2022. In fact, when we got the WHO registration, or when we did it, we were told this is the only sixth such study in the world on microbiome and healthy aging. We started the study in July 2023, and we closed it earlier this year. It was a study of not much, 50 people, but that itself costs a lot. 50 healthy adults between the ages of 40 to 59 and 60 to 80. And we were looking at a lot of data points. In fact, we did clinical data as well, urine, bone mineral density, ECG, blood sugar, and of course, a lot of metadata, PSQI, the wellness scores. We looked at all of that. And we, as systems biologists do, we started correlating it. In fact, the objective of the study was to see if there are bacterial patterns, if these bacterial patterns could find signatures or could find patterns in the phenotypes of the people, and if these phenotypes actually had any emergent patterns. And of course, we wanted to study the whole food piece intricately. And you see there, we had 18 data sets, which we nicely organized, right from risk of diabetes to risk of cardiovascular diseases to even the Ayurvedic constitution, your Vata, Pitta, Kapha, to see how that impacts it as well. Besides the microbiome and the food frequency, we had 195 data points. Of course, the microbiome data was whole metagenome sequenced, and we had extensive amount of data. The food frequency questionnaire, we had about 430 odd data points on how food and nutrition actually impacted the other pieces, right from blood to liver to all the other parameters that you see there. What this resulted in is, well, this study, we're just still analyzing data. We closed the study in January this year. What this resulted in is something like this. Now, I'm sure most of you can't read this here, but we found very specifically about 153 correlations between these different patterns. What you see there in green are the ones that we have strong correlations. In fact, the strong correlation is between the liver data and certain microbiome data. There's a strong correlation between your CBC, your blood, and microbiome data as well. As you can see that we had about 36 strong correlations, and about 7 weak correlations, but then there were correlations anyway. Now this data is for one part of the age group. This is for 40 to 59, and I can assure you the data for 60 to 80 is very different from this. So just that, the data patterns that you see between two groups of elderly people, or rather, well, not elderly, but healthy adults and elderly, were distinct. So there's a lot of these correlations that we found, and there's more work to be done. And I like what Chiranjeev said, there needs to be more collaboration. We can't do this on our own. We move on. Some other things that came out of this. We connected some of the microbes to what we call aging hallmarks. I mean, this is a room full of people who know about aging, so I'm not going to talk about the 12 hallmarks of aging. What we did, we connected 838 bacteria, microbial species, to about 262 metabolites. And then we connected that to the 12 hallmarks of aging. Now, you may not appreciate this in a tabular thing like this. What we did was we followed mathematical principles, systems principles of graph theory. We appreciate this a little better. This is what it looks like visually. There are 838 microbes. They produce 262 different metabolites. It can be first order, second order. This is very important because it's not all bacteria that produce all the metabolites that you need. I see the team of serotonin here. It's not that all bacteria produce serotonin directly. There are different pathways. So one bacteria could consume something, produce something else. That could eventually become HPA and HCA and something else. So this is the graph. Now, you may appreciate it a little better if I show you this. So if I were to look at one of the hallmarks of aging, mitochondrial dysfunction, we just spoke about it, and then say what are the microbes or the metabolites that are impacted by or impact mitochondrial dysfunction, there is indole-3 lactic acid. Indole-3 lactic acid, and then connected to other microbes. One of the reasons I think microbiome studies didn't really get to what it should is partly because some of those microbe names are almost unpronounceable. Anyway, 2 of them. And if I have to look at chronic inflammation, kynurenine, 3-HA, and indole-3 again, those are the metabolites that affect that. And those are the bacteria that connect. Okay, this is just representative. But you can understand where we're going with this. Identifying the bacteria and the metabolites is part of the problem. The next part of the problem is how do you optimize it? An ecosystem has finite resources, right? We know that. How do you optimize it within the finite resources? How do you make sure that you have the right bacteria that can produce this as well as the others? And of course, this is just, we have just taken 2 hallmarks and very few metabolites. It's an extremely complex problem to solve. And when I say it's an extremely complex problem to solve, it's by an exponential degree. It's not linear. It's non-linear. So yes, this is where we need a lot more work, a lot more time to do things. And I'm hoping a lot of people here are interested in how to do this. But this is the kind of work that has gone in, and a lot more has to happen. So I was told very clearly to say what is the vision and what is it that we need to do with Longevity India team. Of course, our vision is to do a lot more on the omics, understand, and the omics not from a point of view of looking at the connections, but in terms of view of finding a solution, finding therapies. And I know a number of people here can help with some of these. In fact, imagine having this, finding the right metabolite, and then having a system like the gentleman present to the Dumas saying, give me this combination of metabolites, give me this combination, and lo and behold, and voila, you can have a pill or something that you can consume. So targeted interventions is something that we really like to do. Somebody spoke about the study recently published, Stanford study, where you have exponential growth or nonlinear aging at between the ages of 44 and 60. At least from the study that we have preliminarily done, it doesn't look like it's the same age groups that matter here or the same age periods that matter here. I think India is very different. Can we do something for India here? I think the answer is a resounding yes. And yeah, we all need to do that. There's a lot of thing about collaboration. Again, back in the work that we did here, I did here, and I'm sure there are people here, you need an India stack for healthy aging. Well, I tried India stack for longevity. It didn't really work. I think India stack for healthy aging as Isha sounds better. And of course, people said, contribute our platform, happy to put in our platform. There is all of this in terms of, modeling the metabolites that you need and then modeling the metabolites in a way that it can cause a therapeutic impact to you. We also saw n is equal to 1. Prashant spoke about n is equal to 1 in his presentation. That's the problem we need to solve. But maybe there are intermediate steps that we can take to address it. So these are ways in which you can collaborate, simulate, and validate. A lot of these things need. We can do a lot of simulation. We can do a lot of probabilistic calculations within the system that we built, and together I'm sure we can do a lot more. But how do you validate it? How do you validate? And a problem to solve for n is equal to 1 is far more challenging than probably solving it certain groups, taking smaller chunks of the problem to solve. So things like this is where I see we can collaborate and do stuff. Thank you very much. Faster than the bell.
Any specific shifts that you saw from global data on these metabolites that are in play here in the Indian context for this
Yes,
dysfunctions?
I think the answers are clear, yes.
Yeah.
If you ask me now what all, I really do not know.
And then what will it take for us to find out a reasonable set of those?
So this gave us about a few terabytes of data, Prakash. To go through this in a small team is it's a humongous of effort. Maybe some more time, maybe some more resources.
Okay.
But I think we'll get there.
Got it. Thanks.
I have certain questions here. I'm from V-Proteomics, here on your right side. So what I could understand, the study was designed theoretically. I mean, you have a repository of lot of bacteria which are from the gut, and you have certain signatures which are metabolite specific. And finally, you have 12 metabolites which are, these are 12 signatures, right? Which are identifying a particular kind of bacteria pattern.
No, sorry, let me clarify that.
Yeah.
The study, so there are two parts. One is the 12 hallmarks of aging.
Yes.
And we were trying to see, our first primary thing was to see if there are bacterial patterns to define aging. For example, if there was a person, we were looking at only healthy people. We were looking at, and this resulted from, which is that book which talks about all healthy people, all healthy families have one pattern for happiness, but all unhappy families have different methods. So we were trying to see the patterns for healthy aging, and I think we have seen these patterns for healthy aging. That is one. The next we were trying to see was, now that we've got these details of both from the blood and from urine and from the microbiome, whether there are correlations with this. The third was to see, only from a microbial species level, which of these microbes contributed using the pathways, which are metabolites, to individual hallmarks of aging. So there are these 12 hallmarks of aging. We spoke about in the morning: genomic instability, telomere attrition, epigenetic alterations, mitochondrial dysfunction. So we were trying to see which of these metabolites, and about 8 more, cellular senescence, dysbiosis, chronic inflammation. These are all some of the others. Which of these metabolites contribute to that? That's what the study was about.
So what I was asking, like in the circus plot, you were showing example of metabolite after another metabolite.
Oh, that one.
If you go back.
This one.
Yes, like.
Yeah.
Chronic inflammation, and then on the left side, you show the metabolite which may be responsible for chronic inflammation, and it may be related to a particular genus.
That's correct.
Or bacteria, right? So why the numbers are only 12?
No, that's because if I talk about all of them here,
okay.
I'll take the rest of the afternoon.
So here, for example, only the numbers are 12. So you
have. This is just to give you an example. This is illustrative.
Yes. Okay. Yes. Second, for the validation, you have never done it on a.
No.
Okay. Thank you very much.
We have not done it. Yes, please.
Have you seen associations between specific metabolites, microbes, and the marker RDW?
What is REW? No.
So it's a marker for inflammation as well. Your blood gets thicker and REW is increased and it's reflected.
Okay. No, I think we were looking at specific.
Will you be able to? Is it there in your data set? Will you be able to take a look at it?
Certainly. Why not?
Okay, I have a question regarding the establishment of the cohort. You said 50 healthy individuals. I want to know your selections criteria for healthy individuals because when you're talking about microbiome, and I think this is one of the biggest challenge, that what you call yourself to be healthy.
Yeah.
That's the first question. And what were your criteria of selecting those selected 50 individuals? Second is, all these are correlations. So we have to be very careful that these are not causalities. And unless and until we have a set of healthy and a condition that we take, in this particular instant, maybe faster aging being one of them, we cannot come to any conclusions because these are just correlations. They might be true, they might not be true. So what are your criteria for healthy first?
Let me answer take your second question first. Sorry, I don't know if that's the point. But these are all correlations. I think we're completely cognizant of that. We don't yet have the ability to say that these are, in fact, what I forgot to mention was we are looking at it over two time points. Point 1 time point, which is day 1, and day 30. And for these two individuals, I mean, for the same individual across, I mean, all these measurements are taken twice. And we know it's correlational. We had we were under no illusion that it was causal. The first part of the question, healthy adults, well, people who didn't have cardiovascular diseases, people who didn't have diabetes, all these other sicknesses that are commonly available, that are commonly prevalent. To get 60 to 80 age group people, I mean, to get them was extremely difficult, and the study actually gotten delayed because of that. So we were sure that people who didn't have any of these traditional diseases, I mean, we have a strict exclusion criteria, rather long one, but no illnesses, no sicknesses, not even any condition or having gone through any trauma. So it was both physically and mentally they were classified as healthy.
I have one question. Hi, this is Monolekha from Project Serotonin. While I understand that the species on the right are not causal for the inflammatory markers, they are correlated.
That's correct.
Many of these markers are actually seen upregulated in chronic inflammation. It has been well documented, especially in indole-3 acetic acid. And we do see in West, there are various niche startups which are focusing on indole-3 acetic acid as a marker for inflammatory diagnosis. We don't see that here. And do you see such shift coming, given there's a lot of data as indole-3 acetic acid? Because what we see is CRP, ESR, all those things.
It's interesting you bring up indole-3 acetic acid because it is seen as one of the potential biomarkers for healthy aging. But having seen that yet, no, we haven't seen significant changes or differences between data there in the West and us. Because I don't know if I mentioned this, but we also looked at very very clearly. When we did, which is why we have so we got data from 81 published papers, and it's not just published papers that we went through. We actually got data, contacted those folks, and got the data. Well, I would still say maybe we can collaborate with the team here and maybe accelerate some of these findings. But there's a lot of data that we need to go through.
Thank you so much. Very nicely said there.
Hi.
We can collaborate more. I think we can take up the questions later. Thank you so much.
Thank you.
Thank you.